So this video is for example 3, and example 3 is a temperature measuring system, and this particular system is an RTD, a resistance temperature device. The actual RTD itself is sat just under that cable block. You can just see it right under there, and the probe, which is in the region of 18 inches long, goes through what is called a thermal well, and that thermal well goes into the tank. The information coming out of our RTD uses 3 cables that you can just make out here, 2 reds and a white. The signal coming from there is resistance. At 0 degrees C, it's 100 ohms. At 100 degrees C, 138.5 ohms. And at a minus 10 degrees C, it is roughly 96 ohms. So we are sending resistance now as a signal via that 3-core cable. The 3-core cable now goes to what is called an RT to I converter. So on the right hand side we have the resistance signal coming into the device. On the left hand side, that green cable is a 2-core cable, heavy duty steel wire armoured cable, and that is now carrying 4 to 20 milliamps out. So that device we are looking at is an RT to I converter. If you go through the theory of operation, it will all be based around a Wheatstone bridge. So we have 4 to 20 milliamps now exiting that device, and that now heads to the junction box. So the 4 to 20 milliamps that left the RTD now comes into the outside junction box on the plant. From a 2-core cable, it now goes into a 40-core cable, and this is much easier to transmit the signal. That signal now, which is 4 to 20 milliamps, now heads out and heads towards the control room. So we're in the control room now, behind the panel, and so our signal from the RTD now comes into here, and from the junction box initially it goes to our trip system, and there is the trip system. In particular, what we are looking at is the number TI004 down there. That device is called a trip amplifier. A trip amplifier. And what it does, it takes 4 to 20 milliamps and it turns that into a switched signal that is on or off, like a switch. So it's on or off. That switched signal now goes into the trip system, and that there is the trip system. And so in the event that the outside temperature drops below -1 degree C, that signal, which started out as an RTD signal, resistance, converted into milliamps, then into a switch, on or off, will now cause the plant to trip, preventing us from running the plant when the temperature goes below -1 degree C. In addition to the trip system, we also, as you can see there, we get a temperature indication also. So this is quite a complex system, but yes, it provides indication, but predominantly it also acts as part of the trip system. So in the event that the temperature goes below -1 degree C, it stops us from starting the plant. At that point we have to check to make sure that everything is safe and capable of working, that things haven't froze, etc. So that is our safety system.